the Raspberry Pi Model B that I'm working with, and it's a device, this big. Has ARM processor. It has 512 megabytes of RAM, 700 megahertz ARM processor, and it's basically just a very small computer that you can take anywhere. How many people in here have worked with Raspberry Pi? Awesome. So glad you guys came out tonight. For those that haven't worked with it, it's like, as you see here, 41 bucks. You can have a computer, and there's so much potential as to what you can do with it. There's a very large community around the Raspberry Pi. So you go here, you buy one, Amazon ships it to your house. You can then get on Google and type in whatever it is you want to build, whether it's a robot, whether it's a kiosk like what I'm going to show you guys here tonight. Whatever you can imagine building, you can basically do with this device and the community around it. So there's a lot of other cool add-ons that you can bring in, and you can actually get out your soldering iron and solder things onto it and just do all kinds of crazy stuff. So very, very cool. All right, so let's see here. So to get started with the Raspberry Pi, there's raspberrypi.org. You can check that out. There's also this cool, Google has done something really cool with it called Coder. And it's basically a, actually, I'll just play the video and let you guys watch it. So I'm actually going to run this for you tonight because I have a Coder disk. I don't think I have audio hooked up, so I'm just going to turn my speakers up really loud. Let's refresh that.
These days, knowing how to code is like having a superpower. You can make almost anything you can dream up. But there still isn't a simple place for new coders to get started building cool, real stuff for the web. Maybe you've heard about Raspberry Pi. It's a little machine that helps teach kids how computers work. We got to thinking, Raspberry Pi could be great for teaching how the web works too. So we built something for Raspberry Pi called Coder. Download it, put it on an SD card, and plug it in, and it turns your Raspberry Pi into a simple place to write code and a mini web server to run it on. Everything you need to get started making real web things using the real languages of the web. It's also a simple, cheap way to get a server into a safe learning environment, like a classroom or living room. Coder is open source because we know there are tons of different ways of teaching and learning, so everyone, including you, can help make it better. This is just the beginning, a little download for everyone to get started.
All right, so this is Coder, and I have it on a disk here. And so what I will do is actually plug it into my Raspberry Pi. Actually, let's do a quick exercise so I can shut down my Raspberry Pi that I already plugged in. Let's see if we can get it on. That's not it. So this is the fun, the first part of the fun of finding Raspberry Pi on your network. And what I'll do is actually, I'll just go ahead and unplug it. I'm not even going to shut it down the right way, because I'm crazy like that. Watch this. Here goes the power. Bam. All right. Not going to waste any more time. You guys are spinning your... We'll see if it's on the network after that boots up. So can we switch it to SVGA and see if it's, or I'm sorry, to VGA and see if it's booting? There it goes. Okay, so it's booting. How did you switch that? Just press the...
I can switch to VGA here, but if you want it back on the AirPlay, I gotta go
I
from
see.
there.
Okay. All right, so we're waiting for it to boot, and from here, the video I just showed you, we're going to run Coder. So as you can see, Coder is ready. It's on the login. So basically what it does is, this is actually served headlessly, and it's just creating a web server, and we're going to log into that. So if I can get the AirPlay back.
Does that use a VNC to get into that?
No, it does not. Actually, so what we're doing is, throughout this talk, I'm going to be switching between VGA, which is, that device is plugged in. The Raspberry Pi comes with an HDMI output, so you can plug it. It has no other way of plugging into any other display device except for HDMI. So what I'm using is a HDMI to VGA converter, and those are like $5 on Amazon. I'll show you. I'll go over the details in a minute. But right now we're converting that HDMI signal to VGA, and that's how we're getting it here on the projector. So let's see if Coder. Local, yep. So we are on the network. Cool. All right, so I just want to ping that. Let's see what that is. That is .99. All right. So the first thing Coder asks you to do is set a password. We'll just set it to pi. Save my password. Ah, come on. Complexity. 3.17. Think 1, 2, 3. Think 1, 2, 3. There we go. So now that we set a password, this is Coder. And basically, it's really kind of to teach your kids how to code, to teach anyone who's new to the web how to code. It's got some really cool things. So it's, you say you got it, and then you can go here and try some of these different things. So let's see what Hello Coder is. Get started with Coder by exploring this app. Click the edit button to dive in. It's at the top right, so we can edit. So it shows you how to edit HTML, CSS, and JavaScript, and kind of and Node.js is on here as well, and kind of how to play around with that. It's pretty cool. You can also do this space game, which my 5-year-old son loves. Let's see, how does it start? Yep. So, just a little bit of all right, so I can sit here and play this, drink a few more beers, and reset. Okay, so you can jump into this and see how it's built.
Wait, does it have the spaceships too?
What's that?
Does it have the spaceships that come in range?
That was asteroid too.
Oh, I don't know, man. I know, but so the cool thing is, like, if you've got some kids that want to learn how to code, or anyone who really wants to get into the web, I mean, this is it. This is, you buy a Raspberry Pi, you set it up in your home, and you can instantly kind of learn how to write a game in HTML5, which is really cool. So that is called. Yes.
Hold on real quick. Anybody with the blue Prius down on lot A, you're blocking somebody in? Anybody?
Oh, that might be me.
Okay.
That's awesome.
Can you go and move your car, please?
Yeah.
Okay. Or,
So Coder is one of the many ways you can use Raspberry Pi. Plug it in, get your SD card, bam, that's it. All right, so let's move on. I just wanted to explain kind of the community and the growth that's coming with this device, and there's so much more to it. This is kind of the web side of it, but there's many more sides to this device. So let's see. All right, so let's get into the to actually messing with the Raspberry Pi. This is the fun stuff. So, got my SD card, and so the first thing you're going to do is you're going to buy a Raspberry Pi, and you're going to have an SD card. This 16 gigabyte SD card is like $11 on Amazon, and it's plenty of space. The minimum amount of space you'll need is 2 gig, or actually you really need the minimum of a 4 gigabyte card, SD card, to write a operating system to it. So you buy your Raspberry Pi, and the first thing you're going to want to do is download Raspbian. Yeah. Raspbian is a Debian derivative for the Raspberry Pi, and it's an operating system like you've heard of Ubuntu, or there's even a Ubuntu instance for the Raspberry Pi. But this is kind of like the default operating system for this device, and you'll basically go here or to raspberrypi.org, you'll download Raspbian, and you'll have to write it to your disk. So how do we do that? So you take your disk, put it in an SD card reader. If you have a Mac, that should be by default. And you open up a terminal. So everything I'm going to show you here is Mac-based. If you don't have a Mac, I'm sorry. There are many, everything I'm doing here is explained in a Windows environment. So if you have Windows, that's no problem. Like I said in the beginning of this talk, there's such a huge community around this piece of hardware, it is not hard to find what I'm explaining here. So just bear with me. You can still install Cygwin on Windows and have the same kind of feel what I'm doing here. So if you don't know what Cygwin is, you're a Windows user, download it and use it. Yes?
Hey, Wes, are you going to mention noobs?
Yes.
Okay.
Yes. That's right. I guess I could do noobs instead of Raspbian.
Yeah.
Are you just saying you're SSHing to the box? Is that what you're saying?
I haven't SSH'd into it yet. So we just saw Coder. I would basically explain there's a community around this device. You can go download, or you can get a SD card with the image preloaded onto it. You can plug it in and instantly start learning something. You can learn how to code HTML, JavaScript, CSS, Node, whatever. So now we're going to get into the actual, okay, I just went to Amazon, I bought the device, now I'm going to have an SD card, and I'm going to load an image onto it. How do I what's an image? How do I load it on there? How do I get this thing booted up so I can actually use it? So, like Pratik said, there's this other thing called noobs. Raspberry Pi. And this is like, really your default starting point is raspberrypi.org. And they say, you know, when you get the device and you're ready to start, they recommend this software. And it's basically, noobs actually is an image, and you download the zip file, and then they explain how to get it on your SD card. It's basically like a copy and paste. You don't have to write the image. You can just basically download the zip file, unzip it, Control-C and Control-V onto your SD card. What I'm going to go over is a little more advanced. So you guys bear with me. If you have any questions, feel free to speak up. If you have a better experience with it than what I'm explaining, this is completely open forum, so please interrupt me and speak up. So let's see. So there's noobs, which is basically going to get you to where I'm at. The problem with noobs is that it's a copy and paste thing. They recommend a minimum of a 2 gigabyte card. So when you copy and paste noobs onto your SD card, and let's say you have a 16 gigabyte card like I have here, it's only going to partition you out to 2 gigabytes. So you're going to be wasting the other 14 gigabytes of space, and then you have to get into resizing partitions and gparted and all these other things that it's just such a rabbit hole to go down. It's really just better to do what I'm doing. You know, if you're new to it and you need to understand it better, download noobs, use the 2 gigabyte partition that they give you, and move on, and then go down that road as you feel inclined. But so what I'm going to do here is if you have a 16 gigabyte card, you can write the operating system to it and use the full 16 gigabytes. And so that's what we're going to go over. All right. So first thing is I just inserted the SD card, the 16 gigabyte card, into my laptop. So we're going to pretend it's new. So what you have to do first is format the card. And so let's see, where is that SD formatter? There's an app for SD cards. Oops. That will basically let you format the card. And it automatically kind of picks up the card, so we're at 15.7 gigabytes on an SDXC reader. You can do a quick format or an overwrite format, which does like all the writing to zeros instead of just a quick format, and you can give it a name. And so this is the first place you start with your SD card. You format it, right? Just like the old floppy disk.
Is that part of it, OSX?
No, you have to download it. It's called SD Formatter, I believe.
This is a similar application for Windows as well. It's called the same thing, SD card formatter, SD formatter.
Yeah, this is a SD formatter for the Mac, and then the SD card formatter for Windows. So that's where you start. You format your card, and I'm going to post this document that I'm going off of to the meetup page, and anybody who wants to follow along can. So the next thing we're going to do is type in df-h. After we format the card, we have a new card, and it's going to be like, so here's your hard disk. You don't want to mess with that. You want to make sure that you know the size of your SD card. So mine's 16 gigabytes, and I know that, I don't see 16 gigabytes, probably because I've already formatted it. Yeah, so this is already formatted, but if it was a fresh format, you would be able to see something here that resembled close to 16 gigabytes. You don't want to mess with the 218 gigabyte drive, or the drive that has that many gigs available. So we know for a fact, after you're sure, you know what that drive is. We know it's disk 1, not disk 0. We're going to basically unmount the disk with this command. And so you'll unmount the disk, and you'll see unmount of all volumes on disk 1 was successful. And from there, you can go on to write your Debian image or your Raspbian image to that card. That's it. It was like 2 steps. Plugged in the card, I formatted it, I read it here, and then unmounted it. So now I'm ready to write that card in a Windows or a Unix environment. So, so yeah, we formatted it. So when you're writing the card to disk, you use this default program that comes with Mac or any Unix environment. It's called DD, and you give it an input file, and Wheezy Raspbian is the version of Debian that I'll be writing to this disk. And then from earlier, we saw disk 1 was the disk that we unmounted and we formatted and that we wanted to write to. Again, double check. Always make sure you're never writing to your hard disk when you do these kinds of things. You definitely want to be sure. It's a very unforgiving environment. Sometimes you need a block size on your disk. Every tutorial that I ran through recommended having a block size of 1 meg when I wrote this to the SD card, but when I did that, my Raspberry Pi wouldn't boot. So I just left the block size out, wrote the image, and everything worked fine. So I don't know why that was. I'm not a disk expert. Yes?
Well, I was just wondering, is that because they're trying to make sure that you maximize your space so you don't break your SD card early?
Yeah, it could be. It could have been. I'm not, I don't.
Well, okay, I can tell you why.
Okay.
So it's basically like this. 1 meg would be then the minimum allocated size.
Yes.
Instead, not 1,024 bytes, but 1 million bytes per file, or per allocated unit in the allocation table. So you never want to do that. So basically, bigger drives have bigger allocations because it's all in how the allocation table, thinking in terms of hard drive and sectors and
Yeah.
and all that. you never want to do that. So smaller drives, like a 2 gig drive, it's tiny. You never have a one meg thing. It basically, think of the 1 meg size like partitions of your partition.
Right.
That'd be the smallest unit. So even a 2-byte file would take up 1 meg of space.
Right. So by default, DD does 512 kilobytes.
512 bytes.
I think it's KB.
Precisely the sector.
Yeah, I think it's KB, but you'll have to look it up. I do the man page. But anyway, so I just know by leaving it by default on the block size, it worked for me on a Mac. So basically by writing this, I downloaded the Raspbian image from, let's see, Raspbian, right here.
There's a Win32 disk imager that's just a drag and drop. You just tell it what file you want to load to your disk, and go. You don't need to use a command line.
Yeah. So that's with the Windows environment. There's some really good graphical tools you can use. If you're on a Mac or on a Linux machine, you've got to go this route. But it's only been 3 commands so far. It's taken me a while to explain those 3 commands, but it's only been 3 commands.
Most of the time, make sure that you don't do the wrong one.
So
DD is equivalent to Ghost or to Honest.
yeah, so basically, you have noobs, you have a raw image, which is what I'm explaining here. This wheezy Raspbian image, which is really hard to see. Why is that? Just a bit. So you go here, you download that, you write it with DD or with your Windows utility, and that's it. From there, you have a new operating system on your SD card. Here. Okay. So let's plug that in.
Copy the zip format, the unzip.
What's that?
No, you copy an image.
No. So when you expand the zip file, I should still have it on my desktop. I know. So anyway, you'll download the zip file and it'll extract into an image file, which is what I have here. So it will look like this. It'll be on your desktop and it'll be called Raspbian.img. And you will basically put the file that you just extracted and write that to disk.
So I assume that DD expands it to enable the 16 gigabytes, right?
Yeah, so it writes the partition to allow for resizing, I believe. Or it either resizes it on the fly. I believe Noobs resizes it on the fly, and Raspbian
does it after you boot.
right. Yeah, it makes it available as an extra partition. Yes, or not even as a partition, but as an extra mounted drive.
When you first boot into Raspbian, it lets you expand to fill the disk.
Okay. Yeah, I knew there was some. Noobs has a utility that lets you expand the file system out past the 2 gigabyte default, but it didn't work for Raspbian or something crazy. So I was just like, forget this. I'm just going to write Raspbian to the disk and let the magic happen. So let's plug this in. There goes Coder. Come on. There it goes. Can I get, where's Greg at? Is Greg around? I think. Did that do it? This will work. I know you can switch it up. Here it goes. Okay. Yeah. That's it. Okay. So we wrote our Raspbian image to disk. This is actually a modified Raspbian image. It's the result of everything I'm going to show you tonight. So what I wanted to do was create, I downloaded Raspbian, put it on the card, but I wanted a environment, I wanted a device that would automatically boot into WebKit full screen and display a site, like a kiosk, basically, but something that I'm building for a specific use case. Your use case may be different. Mine was to boot, to strip down the X11 environment and to only go into a WebKit-based browser. So that's what this will do. And then we'll go over kind of each step.
Does he have a terminal for it?
It does. Yes. So we can SSH into this device. We can VNC into it after you kind of go through all the steps that I'm about to show you. So it does take a couple seconds. All right. So there we go. There's WebKit. Let's see what happens. Okay, so I'm going to explain my use case to you, why I created a device that does this. But it basically boots into a poll. So you can pull out your mobile phone and go to the address at the bottom of the screen, or you can open a web browser. Any web browser will work. Let's see if I can do it here. onslide.com/go/
You like polls, don't you?
I love polls. I look for polls. All right, so watch this. So it brings up a remote control, and so the question is, does this excite you? And you can say, yes, I like this, or no way, it's not for me. So I'm going to say, watch this, I'm going to say, yes, I like this, and bam, it appears on the screen, just like that. Instant poll. You can agree or disagree with me. You can vote. You can do whatever you want. So it's like instant satisfaction. You know, there's an audience. You can say, I agree.
How many times can you agree?
Just one, unless you refresh the page. So don't refresh the page. That's just there for fun. So yeah, this was my use case. So the conference that Gunnar and Pratik were talking about earlier, when I first started talking to you guys, they're going to use this Raspberry Pi for each track. So they have 10 tracks of people that are going to be talking throughout the day, throughout the conference. And basically we're going to have this Raspberry Pi, and it's going to have a splitter. So I also have this VGA splitter, which allows you to plug in another presenter, so to speak. So while the audience is seating, everyone's going to answer a question. Or they're going to have the option. They can pull out their phone, go to this address, and say, I want to, I agree with this, I don't agree with it. But when the speaker comes on deck to actually give his talk, he'll plug into the splitter and press the button, and he'll start giving his talk. So it's a way of entertaining the audience while they're coming in to sit, or while the speaker's getting ready. And it basically allows, and what we're going to do is sell, or maybe sell, I don't know, maybe give away the slots to the sponsors, but we're going to allow the sponsors, the people who have a booth set up in the conference, they're going to be able to ask the audience a question and have the ability to connect to the attendees there without just coming up to them and trying to sell them something. So people can sit down, they can pull out their phone, and they can say, yeah, I'm interested in a new job in Node.js. And from that point, that sponsored question will have that person's email, and they can get in touch with them later. So it's kind of, this is a project I've been working on for a couple years now, and really trying to figure out where it fits in. So the Raspberry Pi allowed me to realize that use case. So at a conference for 10 tracks, you have to buy 10 Raspberry Pis, all the setup gear. It's really cheap. It's less than $100 per track to set that up. So for an indie conference like DevNexus that is all volunteers, they don't have a lot of budget to buy all this nice fancy equipment. They can just get a couple hundred, or for under $1,000, they can have their whole conference set up and help their sponsors out, make a little extra money, And that's pretty much it. So that's the use case for me in the Raspberry Pi. It will definitely be different for you, but that's my use case.
Hey Wes.
Yes?
Quick question, why would you not have one Pi support all the tracks?
Because you have, you're limited by 512 megabytes of memory. You're running a WebKit-based browser, Chromium. It's basically Chrome, the open source version of Chrome. And you need a physical device plugged into each projector. You can't have, there's no way to have one device power all the projectors across the building.
Okay.
So, yeah. So for $50, get away pretty cheap. And sponsors have never been able to connect to attendees in this way. All right. So let's go over how. And again, if you have questions, anything you want to ask, let me know. I'm going to go over like how to find the Pi on the network, and how to get it to boot up into WebKit and those kind of things. So let's do that now. All right. Hey, Greg, how do I get back to the, yeah.
Secret key combo.
You just gotta be tall.
Yeah. Gotta be 24.
Okay. So let's start out with finding the Pi on the network, because even though I have 10 Raspberry Pis plugged into each track, I still have to find those and make sure that they're progressing as a slot comes on board. So for the 10 o'clock talk, we may have one question being asked, but after that presenter's done, that web application that I wrote is going to have to monitor the time and move forward to the next question. So anyway, besides all those crazy technical details, we'll just go over kind of the basics of how to find the Pi, get started, install VNC, and those kind of things. So the first thing is every MAC address for your Raspberry Pi is going to start with this V827EB. So we know that we can look at the network and we can see, okay, here's a Raspberry Pi device and here's my MAC address. So there's a couple commands you can use for this. Let's try to find it. See if it comes up on our network. So there's the V8, or there is one, there's a Raspberry Pi device.
Hey, just so you know, we've got a couple of other Pis on our network.
I thought you were me. But I know this is mine because I pinged and got that .99 address. Yeah, so I pinged it earlier when we had that coder.local namespace, so I know that .99 is mine. So what I did actually for that poll you guys just took, the MAC address is sent as a request parameter. So I'll show you the script I wrote for that. But so I'm able to keep track of my Pis. That was the biggest thing, is how am I going to monitor 10 separate devices over each track? And so we'll go over that. But for this, I'm just trying to find this guy on the network. So we know that it is .99. There it is. Okay. So I at there. Yes. Is my password. Okay. So we're logged into that Raspberry Pi. Okay. So now, what do we do? So we use that ARP command. You can also use an nmap command to find it and grep on the name Raspberry. Let's see here. Password. Let's see if it comes up. Wrong side. 10.148.65. So anyway, there's a couple of different commands you can use to find your Pi. These are the ones I'm using. Again, I'll make these notes available after the talk. And let's see. So the next thing I want to talk about. So we've got this. There it is. Yeah. So know that it did not give me the IP address, but that's okay. We already know. The next thing I want to talk about. So right now I have mine plugged into the network, but you can also buy a Wi-Fi. This, I hope it doesn't crash it. So this thing is a Wi-Fi card for the Raspberry Pi.
Really?
Yeah. That little small thing. Yes, USB. So it's supports G and B and all the networks, and it's only like $9. So you can, like I said, everything I'm showing you here was built for $88. And to set up your Wi-Fi for this device, you have to go in and do a few things, mainly with your network interfaces. And you basically have to, it's really simple. Once you open this file, which we'll do here.
It rebooted.
Huh?
It rebooted when you put the dongle back in.
Did it really?
Yeah.
That's not cool. Okay. I guess we'll let it come back up. I did not know that unplugging a USB.
And with ours, unplugging it doesn't do it. Plugging it back in is what short circuits it and causes it to reboot.
Really? Wow. Huh. So yeah, that's another good note about these devices is the diodes in the like for the VGA or for the HDMI connection and for really any connection. It's very power sensitive. Like the plug into the wall is has to be like, and it says on raspberrypi.org, but it has to be like a certain capable of supporting a certain power constraint for the device. You don't want to just plug it into any, like right now I'm using my Android device charger to plug to, and it just happens to work. But you can read a lot of articles on the web that talk about, hey, I plugged this into my Raspberry Pi and it blew it up and it fried it. And so you have to be very careful with the power supply that you're using. And they're very sensitive, obviously. If I just plugged in my,
Do you know the limitation?
I do. Let's see.
I would guess that it's probably a standard USB.
It's like 750 MA, and it's
A standard USB.
It's a 5-volt.
A iPad USB will blow it up.
Yeah.
Because the iPad USB is like 10 watts. That's a much higher amperage. Like people plug their phones into an iPad charger. It'll charge a lot faster, but you're going to kill your battery a lot sooner.
Okay, so it's back online now. Yeah, so you can get that small little Wi-Fi device and not have to plug it into a hard link. And that was, and these are kind of the settings. You would have to go into this file. So let's pull it up. I'll show you. So it brings up this WPA Roam, and that's, if you look at this example, I think this example is a little outdated. I actually use this and connect it to my Wi-Fi at home, but you give it your SSID and your passcode to your Wi-Fi, and it will log in when you reboot it, and it's pretty much that simple. You can see if you're connected to an open. So another question I had: well, what if the hotspot is open? So you can check and see if it's already connected, and then you can do a scan with this command and see what all the available hotspots are. So there's the SSID of Echo Guess. There's the Thinkers. And you can scan and see what Wi-Fi hotspots are available and connect to. You can write a script to connect to the basic to the open ones, I guess. And that's kind of what WPA Roam does. It's already in there by default, and you define your networks in this file. So let's see. So it doesn't have any networks defined, but the basic way you define a network is like this right here. You give it your SSID and your PSK, which is your passcode. And you can create a list of these networks that you know. And so ahead of time, you don't have to log into the device and connect to a network. You can already have it set up to connect to a Wi-Fi network. All right, and one last thing is, even though you're connected to a Wi-Fi network, you have to go into your SSH file and uncomment this address, because right now, the only reason I'm SSH'd into this device is because it's on a LAN. It's hardwired to the network. But if I were to plug in my Wi-Fi adapter and unplug the RJ45 connection, it would actually, I cannot SSH into this device over Wi-Fi. So you have to uncomment this file and say listen address is basically all addresses or all devices, not just EN1. So just a little note there. All right, so now let's get into, okay, so I got my device to boot, but the display is not coming up. And that's a very common problem, is you plug it into a certain monitor and your display won't show up. It won't actually show up on the screen. So your monitor may only support certain formats. So some of the commands we can go through are basically checking. There's a really handy site right here. Let's see, RPI config. And it goes through all the different configs for the device. And let me go over what those are. So the Raspberry Pi doesn't have a BIOS like most computers. It doesn't, when it boots up, it gets all its settings from a text file. And so that's what we're gonna, let's see.
But it does know how to read the text file.
Yes, it does know how to read the text file. So you have this boot /config.txt. And inside of here, everything's commented out. It has a lot of different settings, mostly related to HDMI and display, because this device is capable of producing a high-resolution 1080p output. So you have like some different settings you can mess around with, but you can also overclock it. So anyone who's familiar with overclocking, right now this ARM processor is at 700 megahertz, but if you uncomment this line, it boosted up to 800 megahertz. So you have to be careful with the device, and there's a whole community around overclocking these things because you can easily fry it. But I have
Let's do it.
I've already overclocked this one, and it works to 800 megahertz. I haven't gone up to anything higher than that.
Let's do 1600.
Yeah, let's do it. All right. So, all right. What the hell? All right. So this boot config.txt is kind of the place you go to do any system-wide changes, whether regards to basic regards to how the system utilizes its hardware. So whether it's the display or the processor or whatever, this is the file you would use to do that. And you can try a few commands. So let's see what our display supports. So right now we're hooked up to that projector up there. So let's see if it, you can use these command line deals to see what, so it has 0 modes for CEA. Don't ask me what CEA is. Let's see, and there's also another mode called DMT. Okay, so we know with DMT, we have a mode 16, which is pretty common across most monitors, which is 1024 by 768, 60 hertz, and then 4:3 display. So that is what that projector up there supports. Okay? And that's how you find out what you're plugged into. It's not showing up on the display. You understand what it supports. And this mode 16 right here, you see that? So when you go back into your config.txt, you go down here to HDMI mode 16 is what that relates to. So all this is explained in this file. So you have all these different modes for 480p, for 1080i, and different refresh rates. There's a ton of different modes for the different resolutions. Yes?
If you get something wrong in your config there, is it still boot?
I don't know. I have luckily had things right so far. I would imagine it does. It just doesn't show a display. It's related to what you're, changing, I would think. So.
Technically, you could put the SD card in another system and then get access to that file and edit it. If you were to be lost.
Yeah, it's a FAT32 format disk, so you can
SD card.
No?
Oh, yeah, I will. There's actually a few people here that have done some really good things.
Yeah, the remaking that.
They better do it right.
Oh, yes, yes, I do.
Because he said, I'll see.
Also, if anybody's interested in knowing about parking, the gate's going to be up when you leave, so you don't have to pay for anything.
Oh, okay. Okay. We'll talk to him.
Okay.
Hi there, how are you? All right, how are you? Good, thanks.
Okay, so I'm going to share this document real quick.
I'm good.
Let's do a bit.ly.
Do they make any stronger, more resilient versions of that?
I don't know. I know there's
Just the type I know.
Intel.
Oh, yeah.
To be honest with you, I haven't kept up with the space as much. I mean, I know the Pi pretty well, but the other devices coming, I know Intel released something that's like a lot more powerful. There's other powerful
It looks like you
devices.
could upgrade it. I mean, if you know a little bit about
Yeah.
you could probably beef it up.
You should be able to extend it
Relatively.
Okay, so if you want to link to this document that I've made all my notes off of, it's this bit.ly address right here. Bit.ly number
118.
118
You're going to post that in the meeting?
Yeah, I'll put it in the meetup comments as well.
It's like people take it seriously after 5 minutes. Why are you heading west?
Got an offer for the startup out there, so thank you. Yeah, it's the Valley, Silicon Valley. Yeah, down south where the older, more experienced people go.
Do you want to take anybody with you?
Sure, yeah.
I'll move to California.
All right.
Love it.
My schedule's open.
I'll beat
Y'all
you
come
to
on.
it.
Come on.
I'll beat you to it. I'm sorry.
No, I've already seen them. Because I live up in Canton. I mean, I live 45 miles from where we're at right now.
Oh,
And
wow.
You got a big price difference.
Oh man, it's so.
$5 a gallon of gas. At
Not
least.
just, I mean, the rental prices outrageous. Gotta pay to play. All right. So that is the address. I'm going to copy that and post it here. My notes. All right, so now we're good. Know where to get it. Okay, so let me go over one more TV command here. All right, so that tells me. So there's a few commands you can use to figure out what your display is, and you can hard code it. And then if nothing else works and you can't get it to come up, there's one last option here, and that is, oh, I don't have it in my notes. It's up here up top. This HDMI ignore line right here, I'll post it in. This is kind of your last resort up top, but it basically ignores everything and just kind of tries its best to show a display. You can Google it. I forget what the details are behind it, but that's how I got, something to show up on a display that would not support anything.
Last ditch effort.
That's the last ditch effort. So let me put this in the notes. Last ditch effort. Okay, so as I was telling you, let's go over everything. You can't just buy the board and plug it in and everything works. So you have to buy everything around it. The first thing is a power supply, and that is, I actually brought one with me. So when you order this on Amazon, I wanted something that would give me the case, this guy, so you're not just carrying around a motherboard that will fry because your static electricity, you touched it and the circuit's just short-circuited. So this is actually this package for $50.
So you should get two just in case you try the first one?
What's that?
You should get two just in case you try the first one.
I have plenty, don't worry. So this is the board. This is the case. Power supply. I wanted to read the specs of the power supply. So you really have to. Yeah, so it's 240 volts, 60 hertz, and it's like 750.
It'll be 125 volts.
It's 5.1 volts. I'm sorry, 1 amp, and it's 750 mA. So, yeah, I saw the B. What can I say? I'm not an electrician. So yeah, so for $50 you get all that stuff, and then you also, for this use case, I didn't have to have the 16 gigabyte card, but like a 4 gigabyte card was about the same, so why not just buy 16 gigabytes and people can reformat it and use it in their camera, So, yeah. For $11, that's times they are changing.
They also, when I got my Raspberry Pi, they also, like for an extra $9.99, they gave you an SD card formatted with Raspberry.
Yeah, you can do that. I wanted to make sure I got the best quality SD card because I heard some reports that the pre-formatted cards weren't really of the best quality. So that's.
I know I can image it and put it on a faster card.
Yeah, you can.
I just wanted to plug it in and boot it up.
Right. That's where you can just go down to Noobs or to raspberrypi.org, download the Noobs, and do the same thing, copy and paste. You don't have to go through all that fancy stuff I showed you earlier. But yeah, you really want a good SD card. You don't want to just buy any old SD card. And then I'm also using a HDMI to VGA, so I can show it here because most projectors are outdated and they don't have a direct HDMI hookup. So that was another $5.60. And then let's see what else. Oh yeah, the Wi-Fi adapter. For $10, you can get a USB Wi-Fi adapter that's that small. It's pretty cool. And this is the most recommended Wi-Fi adapter for the Raspberry Pi, the Edimax. I just plugged it in today. Actually, I pulled it out of the packaging before this talk, plugged it in, did some quick interface config, and it was up and running on my home network. So super easy to get started with. And then also the cable switcher. So for this use case, $7 for a VGA switch. I mean, just crazy, and it actually works. So, so for the conference, you know, the Raspberry Pi will be plugged in here. This will be plugged into the projector, and then the presenter will have a extension that they can plug into, and we're gonna have somebody switching between, or the presenter will be responsible for switching between the talks.
Do you have a way of getting alerted if somebody forgets to switch it back?
No, we didn't. But I talked to, so this is the crazy thing about conferences. I went to the Cobb Galleria. I talked to the guys that are running it, the tech guys, and we kind of worked out a cable schema so we could run this thing back to the back of the room to where the technicians will be sitting. The audio guys, I guess, will be back there and be capable of switching this thing. So what I'd really like, what would be awesome, is to detect the current, to kind of solder, instead of having these two buttons, replace the buttons, wire that switch into the Raspberry Pi, and detect the current, and then, you know, we're talking a whole manufacturing scheme here, but you can basically detect and say, okay, I don't have any signal coming in here, let's just go ahead and run the Pi. And when I do have a signal, let's run the signal. It's not that hard of a hardware switch. Yes?
Does the Pi have like IOs in it?
It does,
Then
yes.
you could wire that to those hard buttons and just switch
You know,
code.
I hate to think you're maybe over-engineering it, but
No, it's not. You don't want a human. You don't want a human anywhere near this thing, right?
but at the same time, you could like get some raspberry-colored fingernail polish and put it and paint one of the buttons that color.
I don't want any human interaction in a perfect world. Right now, I don't have the time to take this thing apart and actually do the I/O switching. It just, you spend enough time getting the operating system up to speed, which we'll go over really quickly what that entails. But yeah, it's like I said, and Pratik said it before, hardware is the new software, and there's just a lot of cool things you can do. So all of that stuff, oh yeah, one more thing. I had to have a 3-foot cable to go from the Pi to the switch, and that was like $4. So it's amazing how cheaply you can put all this stuff together, but there's a lot to it. So $88, all that stuff, $88 for one track at a conference. Okay, so let's talk about how did I get, so normally when you install Raspbian on the SD card, it's going to boot into an X Windows environment to where you have icons and you can open up things and just like a regular desktop would. So I didn't want that. I wanted X11 stripped down, and I just wanted it to boot into Chromium. So actually, somebody wrote a really useful article that helped me out. And it's called How to Boot Your Raspberry Pi into a Full Screen Browser. So this is what the open source community is all about. So this guy goes through the initial setup, and basically all he did was install a few things, Chromium, this Matchbox thing, and I don't even know what that is, and X11 server utils. And then, you know, I was talking to you earlier about the resolution and how to detect that, and he did some tricks with frame buffering and added some things to config.txt that I was showing you earlier that allowed him to plug in, and he did this for a kiosk situation. So you're in a mall or you're in an airport, they're using a Raspberry Pi behind the scenes, and they just want things to work. They don't want to have to deal with display issues. So this is what he did. And then, let's see, so some other things in rc.local, waiting for the screen to be turned on. I didn't use all of this. Actually just used bits and pieces. And then launching Chromium. So when the device starts, you edit this file. This rc.local is ran when the device starts. And it's going to look in here and it's going to give me a link to this file in my home directory and just say start X, and it's going to start the Windows environment, the X11 environment. It's that simple. And then the file that it links to up here, we did the soft link to, this is what the source looks like. So this is pretty cool. I can actually pull it up on my Pi. Yeah, so the first change I made, I wanted to be able to VNC to all these devices and see what was going on, and if I need to make a change, I make a change. Because the main reason I need VNC is because when you're at a conference, you've got this craptastic authentication page that you have to say, yes, I accept your terms and conditions, and then you can log into the Wi-Fi. Most people, you know, that was just another little hitch that I had to be prepared for, is because most of the times when the Raspberry Pi sees a login page, it's not going to know what to do. So I wanted to be able to, in the morning before the conference starts, be able to VNC in and even have control over all 10 devices while the conference is going on. So that's what this first line does. And I'm using X11 VNC, not tight VNC. There's a big difference, because when you get your Raspberry Pi and you want to put VNC on it so you don't have to hook it up to a monitor, everyone's going to recommend tight VNC. Well, the problem with tight VNC is it spawns a new session for every connection you make. You don't actually take over that default display. So it's kind of like Citrix or that Windows, what's the Windows?
RDS.
Yeah, yeah. So it basically gives you a new session for every VNC connection you make. And I didn't want that. So let's do that. Let's connect. Let's see if we can connect to that device here. Connection, display 0. There it is. So I just VNC'd to the Raspberry device because I have it set up and ready to go. So pretty cool, right? It was simple to set up. Basically just apt-get X11 VNC, and you have a VNC kind of ready environment. So let me log back in. So yeah, that's what this first line does, is it starts that VNC server on my Raspberry Pi, and just has a lot of extra line switches. And then from there, we do some cleanup of anything that's existing or running. And then we clean out existing information. And then here, again, this is not my script. I'm basically copying and pasting from that article earlier. But this guy is basically generating everything to make Chromium run, or the Chrome web browser, to make it to where it can run and boot into full screen. And it apparently needs a database here, a SQLite database, to be able to run properly. And then we disable some screen blanking, color depth, reset the frame buffer's color depth. And then you can also hide the cursor. So I wanted the cursor to be available because I knew I was going to X11 into, or VNC into it. But you can also hide the cursor and make it just completely like a kiosk, basically, and just take the device and kind of run with it. Start the window manager. So this, as you can see in the comments here, it removes the cursor, or you can remove that, and which is what I did, and now the cursor will show up. And then we start the browser. So here's something I actually wrote, is to get the MAC address. So we're getting the MAC address from the device, and then we are appending it as a query parameter to what Chrome is going to boot into. So now, when this device boots, on my web server, I can have a database pre-filled with the MAC addresses, and I'll know exactly which MAC address is coming in to the web server, and I can coordinate with it and supply it with the correct survey questions to ask the audience. So I'm actually going to have like a sticker on each Raspberry Pi that says track 1, track 2, track 3, track 4. So I actually place that MAC address into track 1, and when the track 1 MAC address hits the server, it'll know which questions to pull down. So you have to have some way of identifying the device in this use case, and that was it. So that was it. And so now it boots into the correct thing. Let's see what else. So yeah, we talked about type B and C. That's pretty much it. Anybody have any questions?
What did you implement your app in?
The actual this poll is all JavaScript. It's all client-side code. So there is a backend that has to record the votes. So let's see. So if you guys want to see how many people just voted, when I had the screen up on the, let's see, that's session 221. So we can go out to onslide.com/. Licks 221. It's not working. I was having problems with this earlier.
So your Raspberry Pi was calling your website?
Yeah.
Gotcha.
Oh well. I know it's in the database somewhere. For some reason it's not coming up. I was having some problems with this earlier. But anyway, so the votes that came in, I recorded. Anyway, any other questions? Yes.
Your XNet RC was customized from what was on W code. You had that X11 VNC line in there.
Mm-hmm.
Can you add that to your document?
Yes. Yes. Add that down here.
Yeah.
I'll actually just
Yeah.
add this whole file.
Oh, yeah.
There we go. So that is the whole. Actually, add the file name there.
Yeah.
Okay.
Cool, thanks.
Sure thing.
How much memory is in use right now with all that running?
How much memory? Let's see. So used is 251. So I've got 196 megs free. It's not bad.
He typed it, it saved it, and refreshed.
For peer-to-peer communication, what type of framework or method do you recommend?
Peer-to-peer from Raspberry Pi to Raspberry Pi.
Another Raspberry Pi.
Oh man, there's so many options out there. It's from a web server standpoint or from a operating system standpoint.
Just anything that would let the other machine know that this thing is happening.
Like a daemon kind of thing. Like there's what's the name of that daemon that will let you know when your Raspberry Pi is online? Just there's options. I would just search for daemons. If you're just wanting to know the status of the Raspberry Pis, but it may require some custom solution to be written.
Originally, you were going to show a socket, WebSockets.
Yeah. So the WebSocket piece of this is actually here. When you pull out your phone or your web browser and connect to that address, this browser, Chromium browser, is using WebSockets to
Do you have the code for that? The JavaScript for that?
Yeah, it's an open source project called. See, so there's some votes coming in now. Let's see if I can inspect comments. So I can get my Chrome Dev Tools up here. But it's not going to let me, you have to actually refresh the page, and I can't do that. So if you want to see the code behind the polling system, you can always go to github.com/slide. And that's basically like this guy. If you just go to onslide, it's all JavaScript and HTML and CSS. So this DevNexus display.html is what you just saw.
I'm interested in the WebSocket code.
Cool. Please check it out and contribute patches because there's always stuff that needs to be worked on.
Break it up stuff.
Don't break it. Just contribute. All right. So, any other questions?
I don't have a question, I just want to make a comment.
Sure.
To prevent overheating on the Pi, you can also use heat sinks.
Yes, I've heard of people doing that. So when you overclock it,
Yeah, go right here.
let's see.
You can actually use the heat sinks and
Oh, sweet.
so I dropped the temperature for like 30%, so it just stops it from overheating.
That's awesome. Did you glue these on yourself?
No, the sticks on that.
Oh, sweet. So you stuck them on?
Yeah, no, it was already under here, like you take this off and it has a sticker under there that sticks onto it.
Right, but you did it. You took the sticker off. That's cool. So he actually, what's your name?
Ricardo.
Ricardo, that's right. Ricardo actually put heat sinks on each of the chips in here and reduced the amount of heat it outputs by
a little closer.
By Ricardo put heat sinks on his Raspberry Pi and reduced it by 30%, which is really cool. That's awesome. I like your case too.
Thank you.
Pretty sweet. Is that a Model B?
Yes.
Okay. So what have you done with it?
I pretty much tried out every operating system. I'm actually going to start using Python. I'm trying to figure out noobs a little bit. I'm still trying to get a hold of it.
Mm-hmm.
And
what, like the Linux environment and installing things and?
Pretty much just trying to try out everything. I tried Android on the Raspberry Pi. You know, kind of like it wasn't really a good idea, as like he's saying right here.
Yeah.
But as a whole,
yeah,
learning code, I'm still learning, and I'm still trying to get into HTML5, learning how to make websites and programs. So.
Awesome. Very cool, man.
That's great. Yeah, awesome.
Awesome.
Very good.
Yeah.
All right. So, any other questions? Anybody have anything else they want to share? Anybody doing anything cool with the Pi?
Well, when I got mine like 8-9 months ago. The one thing I worked on it for a couple of days just to see if it could do it, and I was pretty surprised that and I just plugged my like standard little USB adapter to a micro USB, and that powered it. I didn't buy the special power supply. I just had plenty of micro USBs around. Plugged it in, powered it up. I noticed the HDMI out. Put that out to a monitor, and so like, you know what, apt-get install desktop. Did that, got X up, basically Ubuntu type desktop with Firefox right there.
Right.
Hit Firefox, and I was browsing the web. I was like, oh my God, for 35 bucks, I have a web browser, and anybody who knows Firefox could use this to browse the net. So I'm just thinking of all these, you know, any of these cafes. I mean, I don't know, I'm not really into marketing to them, but I'm thinking like, hey, look, you want these Windows boxes to continually get viruses and whatnot? Or how about we just stick this little box with Velcro on the back of your monitor?
Right.
And boot up, everybody's going to recognize Firefox, and you can browse the net if they don't have their laptop, and it's virus tight, and you know, I was able to like watch videos on CNN. I didn't know it could do Flash. I was able to Flash and audio, and I was like, cool. I didn't try it with the with wireless, but there's none of this. It's very easy to configure. It's obviously it comes with DHCP enabled. So.
It's kind of reminiscent of being if you were a PC technician in the early 2000s. It was it's kind of reminiscent of that. You're kind of going back to getting audio working and trying to figure out what's going on with this operating system, but it's not that difficult, right? You're not taking someone's old 200 megahertz computer and trying to fix things, but I lived that life for a short period. But anyway, yes, Mike.
So I've got a question. So would you say that kind of the primary benefit is when you actually do want output and you want to be able to output to something that's really inexpensive? Because when I first heard about it, I thought, oh, it'd be a really cool server box. But I guess I could just put the server in the cloud, and so there's not really a benefit there. But it seems like your value add is the fact that you can put a device that talks to a monitor.
Yes. The value for me is being able to have a JavaScript application that can run and be output full screen. And connect to a server and have network connectivity too. And that's really, really powerful. Yes?
I can tell you that as a Linux server, it's extremely useful if you live with a woman who does not want you to have a lot of computers.
And it's a great media box.
It's all about RaspMC.
Yeah, like the Xbox Media Center, RaspBMC.
Yeah, RaspBMC.
RaspBMC.
Yeah.
And I mean, just for watching, it's capable of 1080p output. So I mean, you can hook it up, Velcro it to the back of your 56-inch monitor, and you're able to stream anything or to really.
I use old TVs to plug it into anything with HDMI. You can plug it right
Exactly. Yeah, it's really cool. It's sad that I'm down converting the HDMI signal to VGA, but for projectors in my use case, I have to.
Right. Older projectors won't do HDMI.
Yeah, you're lucky to find an HDMI projector. Right. So it's cool, and it's cool to be able to run command line switches, see what your display is capable of, and kind of mess around with all that stuff. So yeah.
I do a lot of back-end development, so I have a couple of them, but I'll put MySQL on one and use it as a database server just for the development I'm doing with my PC, just to have it an external server. But I can have a few of those things running, and they're so tiny that they're like disposable servers.
And then when you put the heat sinks on them like Ricardo did, I mean, you can have you overclocked yours yet?
Oh, not yet. But
okay.
I've heard like if you overclock with the heat sinks on, it doesn't do anything like different. It doesn't have a.
Well, it probably allows you to go like I know you can go. I did mine up to 800 megahertz from the 700 megahertz setting, so you could probably go to 9 or even a gigahertz, you know, with the heat sinks on. So yeah. Yeah. Awesome.
You can't compare megahertz or gigahertz. You can't compare those with Intel megahertz. It's an ARM processor, it's not an Intel processor.
Right.
It's way different.
Okay.
If I'm not mistaken, an ARM processor is a risk.
Yeah. It's a reduced instruction set. Yeah.
So it basically 700 megahertz runs a lot faster than a 700 megahertz Intel chip.
Okay.
There's a question right here.
Yes.
So how about capturing user input from an actual monitor, like a multi-touch device? Are there anything you know of that helps kind of capture that and kind of translate that to the actual server itself? You know what I'm saying? Like if you were going to...
It's just a mouse input.
Yeah, I know, but like, are there any kind of touch kind of libraries that you know about that are good for the Raspberry Pi? Because like, this is like seems like basically a web browser to the application you built somewhere else.
For like
I mentioned
kiosk
actually like
system.
in a true kiosk, it's actually self-contained. It captures user input and still talks to the database maybe somewhere else.
Right.
It would just be a USB input. The device has 2 USB inputs, so
okay, good.
Basically every touchscreen plugs into the USB input of to a PC.
So it'd be a matter of the operating
system.
system.
You can wire it up. It's just you gotta.
Yeah. So, no, all it knows is it's a mouse. When you touch something, it's causing an event because it thinks that's a mouse.
Yeah.
It doesn't know.
And there's just like a calibration with the monitor and stuff like that.
Right. Yeah. But that's usually built into the